Hi, hello, good morning, one and all. Today topic is the relation between electric field and potential difference. So, electric field and potential difference or potential. So now here already we know that already very well known topic electric field. Electric field means what? The region, for example, it is one of the charges, so which produces electric field. Already we know very well. So the region where the region means space around the charge where its influence felt by another charge is called as electric field. Field means region, so this is the region. Next, potential means what? Potential nothing but work done. Already we learned previous concept. So work done means what? The amount of work done to bringing unit positive test charge from infinity to that point against the electric field is called as potential. Same like that here. So it is the derive the relation between electric field and potential. That is one way of questioning. And the another way is so derive the relation E is equal to minus dV by dx or dr. In another way, another question is also that don't confuse. So here, prove that or show that electric field at any point, electric field at any point is equal to the negative rate of the negative the negative potential gradient at that point. So that is another way of questioning. So in this type of three questions will come. Don't confuse. First one is show that E is equal to minus dV by dx. Another way is derive the electric field and difference between electric field and potential. And another way is the electric field at any point is equal to negative potential gradient. So that is three ways possible to questioning this type of this question. So don't confuse. Keep in your mind these three questionings. Right. Now derivation. So consider a charge plus q which produces electric field E. So observe here it is positive charge which can be produces electric field like this way. Already we know very well. So now potential. How to denote potential means, for example, in this along the line of electric field, we should consider one point here, one point here. In here, point is moves along the direction of electric field. So potential is decreases with respect to increasing distance or along the electric field. That's very important point. So we should consider here point A. So here consider point B only consider. Where electric potential is greater, at point A is electric field is greater. Electric potential is what? Electric potential means work done. Where work done is more, where which position electric field strength increases, that place only electric potential is greater. So work done is more means potential greater. Work done is less means potential is less. So already last question that electric potential derivation already I told. So now here it is Q charge. It is moving like this way. That means electric field. Here electric field strength it is very weak, but electric field strength is increase. So for example at point A only electric field is there, like that only you feel. So here no electric field is there. Why? Because it is a very less magnitude of charge. So here 1 coulomb of charge, test charge is there. This coulomb of charge can be bringing from infinite distance to point A. Point A is you can easily move. Why? Because here strength is less. But now, actually, our aim is the charge is bringing from the point to point P. That means point infinite to point P at distance R. Once you remember this topic. So, but here up to here it is not possible to bringing. Why? Because here opposition is greater opposition force is there. So that's why we are done or did some small work done from A to B only. So that is dx already we did this question. So that meaning is what? Here somewhat electric field is less. That's why work done is easy. Same like that here, electric field will value will be increases. That's why work done is more work done is required to bring this 1 coulomb of charge. So that time that's same way this charge is moves from here to here means very tough, very tough. So why? Because here electric field strength is more. Electric field strength more means against we are doing work also more is required. So that's why not possible. Actually, possible means not possible to bring from here to here, but our convenient way mathematical derivation is there, integration. So that's why like that only we should follow. Same like that. Here, for example, here potential V is there, here potential V is there. But which potential is greater means here potential is greater. How much potential is greater means it is nearby there. So that's why here plus delta V is there. Delta V. Delta V potential is greater. Delta V means what? Small potential. Small potential is greater at point A compared to B. Understood? So observe here for easily understanding purpose. If suppose these 2 points potential is same like that only there. So right, for example, it is 5 volt to it is 5 volt is there. But here, actually according to electric field ratio, so here 5 volt to 5 volt is not possible. So actually here 5 coulombs charge like this. So, for example here, 5 is there means here potential is greater. How much potential is greater means 5 volt to plus 0.5 like that only field. So that means 5.5 volt. 5.5 volt to it is 5 volt. So that means potential is decreases with increasing distance from the charge. So along the direction of electric field, potential value will be decreases. Potential value will be decreases. Right. So same like that. From here to here, small difference is there. We place delta V. Delta V nothing but here 0.5 like this. 0.1, 0.2 like that. So for understanding purpose, 0.1, 0.2, 0.5 like that only you should take. Understood diagram? Right. So now here, at point A, potential is greater, point B's potential is less. Why? Because work done mainly. Right. So now, A to B distance is dx distance only we should consider. Dx distance or delta x distance like that only you should take. Delta x or dx. Small distance between A and B. That's why small potential differences exist. So right. So now, already we know that potential difference statement. Potential difference. What is potential difference? Potential difference. Potential difference, potential statement both are same, no? But here only small difference is there. Potential difference means the amount of work done is bringing or used to bring unit positive test charge from one point to another point. That's it. Against the electric field. Against electric field is common. Potential means the amount of work done in bringing infinite to charge is bringing from or unit test charge is bringing from infinite distance to point P against the electric field. Infinite means total potential, but here potential difference means the same work done we doing from one point to another point against the electric field. That is the difference. Right. Potential difference. Potential difference here. What potential difference? VA minus VB. So VA is greater potential. So and VB is less potential. So that's why difference is what potential is there? V plus delta V plus minus V only. At B, point V, at A point V place delta V. So now V plus delta V minus V plus V cancel delta V. So it is potential difference between point A and B. So this is potential difference between these 2 points. Okay, right. Now what is meant by potential difference? Work done. So that is very important. So work done is nothing but work done is equal to potential difference. Potential difference. What difference? Potential difference. Potential difference means delta V. Right. Work done means what? dW. So dW is equal to potential difference means what? This one only. Potential difference between A and B. Otherwise between A and B. Potential difference between A and B. So V A minus V. It is work done formula. Right. Continuation. dW means what? General formula? Force into displacement. What force here? 1 unit positive test charge plus 1 coulomb of charge. 1 coulomb of charge is bringing from B point to A point. Again is the electric field. So that's why here force F is F into displacement. Displacement again is the electric field. So that's why here minus delta X is equal to VA minus VB value or delta V. Are clear? Right. Now here F is equal to minus is there, minus delta X is multiplying with F. So this function is move that side. What will come? Minus delta V divided by delta X. Clear? Right. Now here F is there, but what we want? Electric field relation we want. Electric field relation. Electric field, already we know that electric field formula definition. According to definition, the force experienced per unit positive test charge is called as electric field statement. According to statement, electric field is equal to the force experienced per unit positive test charge. Unit positive test charge, how much here? 1 coulomb. So that's why here F divided by 1 coulomb. So F divided by 1 is F only. So that equal to F. So clearly E is equal to what? F only. So now that value substitute here. F is equal to E. So E is equal to minus delta V by delta X. So this is the relation between electric field and potential. Electric field and potential. So it is also written as in terms of differentiation, E is equal to minus dV by dx. So it is in form of delta, it is in the form of d. So that's it. Clear enough? So important, it is very important for 3 marks question. Very important. 3 marks question for IPE or PU. Okay, right. If you have any doubts, comment, so I will clarify that doubts. Okay, thank you.